Children, we were discussing lesson number 11, weight, volume and density. In the previous session, we have discussed about Archimedes principle, which states that buoyant force is equal to or upthrust is equal to weight of water displaced by an object. Now, upthrust is the force which is exerted by the liquid or fluid when something is immersed in the liquid partially or fully. That force pushes the thing in upward direction. Now, children, there is a question that a nail made of iron, a little nail made of iron sinks in water, whereas a huge ship or a boat floats in water. And what is the reason? Now, children, that is the reason is its shape. The shape boat is hollow in shape, right? Hollow means it has air inside it, air trapped inside it. So, and you know that air is less denser than water, right? And most of the space in the boat is taken up by air, so it causes the overall density of the boat to be lesser than that of water. Whereas a nail is denser. The density of iron nail is more than that of water. Due to this, the iron nail sinks in water while the boat floats on the surface of water. Now, we will see the ship with the example of ship, how the ship floats in water. The hollow portion, see, if you can see in the picture, most of the portion in the ship is hollow, and even though the iron used to make the boat sinks in water, the boat floats, the ship floats due to this hollow portion, due to its shape. When the boat is in water, the entire volume of the boat, including the hollow portion, displaces water to make space for itself. Thus, the volume of water displaced is much more than the iron used for making the ship. Now, according to Archimedes principle, when the upthrust is more than the weight of an object, the object floats in water. Children, so a ship floats in water because of its shape. A ship is hollow as we saw in the picture, and the entire portion of the ship, including the hollow portion, displaces water to make place for itself. Thus, the volume of water that is displaced, as the ship is very huge, so the volume of water displaced is much more than the volume of iron used to make a ship. So, according to Archimedes principle, the upthrust is also very high, more than the weight of the ship. That's why the ship floats in water. Now, children, we have discussed about the object weighs less when it is in the water. The weight of an object is different when it is inside the water and when it is outside. Now, weight of object in water is equal to weight in air minus upthrust. In other words, weight of object in water is equal to weight in air minus weight of water displaced, because according to Archimedes principle, upthrust is equal to weight of water displaced. And what is it called? The weight of things in the water is called as its apparent weight. The weight of an object in water is called its apparent weight. Now, apparent weight is equal to weight in air minus weight of water displaced. The loss of weight of an object when immersed in water is known as apparent loss in weight, because when it is in water it weighs less. So, loss of weight of an object when immersed in water is known as apparent loss in weight. Apparent loss in weight is equal to weight in air minus apparent weight is equal to weight of water displaced. When an object is immersed in water, it loses weight equal to weight of water displaced by it. We have discussed this in the previous session while discussing about Archimedes Principle. Now I am going to explain you in detail about weight in water with the help of a video. I hope you enjoyed the session. We will end this session with the video. Children, in the previous session with the help of this diagram, we studied Archimedes Principle. So, what is Archimedes Principle? Yes, upthrust is equal to the weight of water displaced by an object. We also discussed that when something is put in the water, the things weigh less. The thing weighs less. You feel it much lighter. We took the example of a brick. When the brick was outside the water, the brick weighed more, and when you take the same brick inside the water, in your hand it feels much lighter. Now, we know that the weight of things inside the water and outside water are different. So children, today we are going to discuss about weight in water. Now the first thing that we are going to discuss is weight of an object in water. Now here, as you can see, the weight of object in air is 10 kgs. So weight of an object in water is equal to weight in air, that is 10 kg, minus upthrust. Now here we saw that upthrust is equal to the weight of water displaced, that is 4 kg. The upthrust and weight of water displaced is 4 kg. So weight of an object in water is equal to weight in air minus upthrust. Or weight of an object in water is equal to weight in air minus weight of water displaced, which is same as upthrust. So weight in air is equal to 10 kgs and weight of water displaced will be again 4 kgs because weight of water displaced is equal to upthrust. Now the weight of an object in water is called as its apparent weight. As we know that the weight of an object inside the water and when it is in air, they are different. It is not same. So the weight of an object in water is called as its apparent weight. Now apparent weight is equal to weight in air minus weight of water displaced. That is, weight in air is 10 kgs and weight of water displaced is 4 kg. So apparent weight here becomes what, children? 6 kg. Now the loss of weight of an object when immersed in water is known as apparent loss in weight. I am telling again, the loss of weight of an object when immersed in water. Now see children, here the weight of an object is 10 kg and the loss of weight is 4 kg because when it is immersed in water, the weight is coming as 6 kg. So the loss of weight of an object when immersed in water is known as apparent loss in weight. So apparent loss in weight is equal to weight in the air minus apparent weight. So weight in the air is 10 kg and apparent weight is equal to 6 kg. So weight of water, that is equal to weight of water displaced, that is again 4 kg. Okay, because buoyant force and weight of water displaced are same, that is equal to 4 kg. I hope you understood about weight in water.